Lead code problem 118, Pascal's triangle. A problem description. Given an integer number rows, return the first number of rows of Pascal's triangle. We then have a description of what is Pascal's triangle, where each number is the sum of the two numbers directly above it. And we have a little visual here just as a means of guidance. We note that the first value is 1 in the first row. In the second row, it's 1 and 1. In the third row, it's 1, 2 and 1. In the fourth row, it's 1, 3, 3 and 1. And finally, in this case, in the fifth row, it is 1, 4, 6, 4, and 1. So how can we solve this problem? We notice that we are using previously used values, so that means we are probably thinking of a recursive solution. But we can improve it. We can use something called dynamic programming, which usually extends into one of two areas, either memoization or tabulation. Tabulation is where we build a table of solutions, and memoization is where we typically refer to solutions that we have already come across in previous problems. So if we reset our code to the code definition, let us see how we can tackle it. So we are given our function called generate, and its purpose is to return a vector of vectors or a list of lists. The first thing we're going to do is create a private scope to add a few variables, or should I say members, which are just variables found within a class definition. We'll start with an unordered, that sounds wrong, an unordered map. And we'll pass it the parameters of integer and a vector, which itself will only contain integers. And we'll call this a map. An unordered map is basically a dictionary which associates keys and values, creating pairs. We'll also create a vector of vectors, integer, and we shall call it v. A vector is a data structure. It's similar to a list in Python, but we can only store within it a specified data type. In this case, our outer vector can contain itself vectors, and the inner vector itself can contain only integers. It is dynamic in nature, so it can grow. Next, as I said, because it is a recursive function, we need base case or base cases and recursive case. The simplest thing is numRows is found. In that case, so if map.find, this will just search through our dictionary, and we do a find, and we pass in number of rows, and we search through the entire map, and we happen to come across the value. In that case, we will just return v, which again, v is the variable we defined in our private scope. So within our dictionary, if we find the number of rows, we shall just return it. Let me just make sure my syntax is correct. If map.find number of rows is not equal to map.end, so I have a successful search, I will just return that value. Okay, that is a base case. Let me just make it clear. Base case. We have another base case, and that is if number of rows is equal to 1, then our map at key 1 will just be a vector containing the value 1. We will do a v.pushback, so in our vector, we will add that value by referencing the key. We'll do an else if. So another base case, if number of rows is equal to 2. My mistake, why did I say base case? This is a recursive case, silly me. In that case, we will call our generate function. This is what makes it recursive. Number of rows minus 1. We refer to the row above it. We'll then do map at position 2, or should I say key 2, is associated with the value 1, 1, or should I say the vector containing the values 1 and 1. We then do a vector pushback of map at key 2. So let's go over what we have so far. Let's say we are searching through our map and we do not find the number. Let's actually simulate. Let's say I'm given num rows is equal to 1 in my parameter. I'll search. So map.find 1. First of all, we know our dictionary has not been created or not created with any values. So obviously we're not going to find v, we return nothing. We check the next case. Is number of rows equal to 1? Yes, it is. This is our base case. We will create our map that associates the value 1 with the vector 1. And we will have something that looks like this. And within our vector of vectors, we will push back that value, and we will now have a vector containing a vector contain the value of 1. And as you see, that is the first row in Pascal's triangle over here on the top left. And we'll just return that value. Y of num rows is 2. Again, we will check. We do map.find number of rows 2. Because the first time we run the function, obviously this cannot be true. This will not end up running. We check our base case. Is number of rows equal to 1? No, no, no. So that does not run either. We then check our next case. Is number of rows equal to 2? Yes, it is. In that case, we will call generate, and we will pass in 2 minus 1, which will give us 1. Now immediately, once we hit this part, everything else stops, and we return back to the function. We will check again. If map.find 1, again, we don't have the value of 1 in our dictionary, so this will not run either. But what will run is this part here. Number of rows equal to 1. And as I said, at this point, we'll have a vector containing a vector containing the value of 1, which is indicating the first row in Pascal's triangle. Immediately after that happens, control will return past this line, so it will come here, and we will have the value 2 associated with the vector contain the values 1 and 1. We will then push that key into our vector of vectors, and we now have this. A vector containing 1 and a vector containing 1 and 1, which is basically the first 2 rows of Pascal's triangle. And we continue in this fashion. We then do an else, another recursive call, and we will do generate num rows minus 1. We will now create a vector to populate. Int, you can call it whatever you want. I will call mine row, and its initial size will be number of rows, and I will populate them all with the value of 0. So if we have number of rows 3, then I will create a vector of size 3 where all values are 0. I will then say row at position 0 is equal to 1. Why am I doing this? Look to our left. All our first position values in each row is 1. So that's why I'm doing it. And if we look back here on the left at our triangle, all our last values are also 1. So then I do row, and I need the last position, so I'll refer to the size of the row. Right? But I have to minus 1 because that indicates position, and I'll set it equal to 1. I'll be honest, right now I have an assignment and I have not started it yet, but it is what it is. I'll then say for int I equal to 1, I is less than row.size, I plus plus. It should be for int I equal to 1, I is less than row size minus 1. That is what it should be. just so that we don't go out of bounds. I'll then say row at position I is equal to, referring to that vector v, num rows minus 2 at position I plus v at num rows minus 2 I minus 1. This is probably the hardest part of this function so far. If you aren't sure, just print out this value to the console and you'll figure out what it is. Once we're out of this loop, once we're out of this loop, we should have populated our row. So we will add that value. So map at key num rows is equal to row. You'll then do v.pushback, map, and we refer to num rows. Once we get out of all of that, in line, we will just do, should be here. We will do a return v. Let me just make sure everything here is correct. So let's say number of rows, for example, is past the value of 3. This will not run, this will not run, this will not run, this will run. So first 3 minus 1 will be 2. So it'll come back to the function. Now this won't run, this won't run, this will run. It's now 2 minus 1, so this will run. We'll add back the first row, which is just a vector containing the value 1. Control will return back to line 20, so this line here. And what will happen here is that we will add the row 1, 1, and then we'll come down to line 26. We will create a vector of size 3. We'll populate that vector with the values 0 and 0 and 0. We will set the first position within that vector to the value of 1, because the first element in all Pascal's triangles, so each row is 1. So is the last position for all rows in Pascal triangle to be 1. Because we already initialized the 0th value and the last value, we will start an integer at 1, and we do not go to the end because we already populated the last value. We will then say, for example, row at position 1, because that is what it will be the vector at number of rows minus 2. So v at 3 minus 2, which is v at 1. What is v at 1? It's 1 and 1. Plus v at position and 1, and it'll be I, so it'll be 1 and 1 again. So it'll be here, which will give us the value of 1, plus v at number of rows minus 2, which is 1, and then I minus 1, so it's 1 minus 1, which is 0, which will give us the value of 1, which will be equal to 2, which is exactly the value we see here in the middle. Let it come back around, and there we go, 1 plus 1, 2. That is what it will do. We will then push back that newly created row into our dictionary so we can refer to it at a later point. And we will then do a v.pushback. Let's run. Class solution. Am I missing a? That's correct. Correct. Apparently I am. Oh, here we go. My mistake. That should not be there. There we go, and we do a submit. Here we go, we get a runtime of 0 milliseconds and a memory of 11.8 megabytes. Let's get rid of our dictionary. And if we try submitting now, we do get something, and it still works, but notice, we get a 7-second runtime. Dynamic programming, as I said, lets us refer to solutions that we already have come across within our problem. So by adding the dictionary, we make our function a little more efficient. And that is all for Pascal's triangle.